Hello children, welcome back to the science class. Previous session we have completed unit 1 heat lesson. In this session we are going to see about unit 2 electricity. We use electricity in our day-to-day life. Have you ever wondered from where we do get this electricity? How does this electricity work? Can we imagine a day without electricity? If you ask your grandfather, you can come to know a period without electricity. So, the sources of electricity are electrical board, batteries, portable generator, power lines, power station, transformer, electrical board, home electrical and bulb. From these electric power station we get electricity. Sources of electricity. Shall I ask one question for you? How do we get light by switching on the switch? Yes, the nearest electricity board and inquired about the electricity. Let us look into the picture. These are the sources of electricity: wind, solar, hydro, geothermal, biomass, and solar cells, windmills, atomic power stations, thermal power station, hydel power station. These are the sources of electricity. In this lesson, we will see one by one. First, we will see thermal power stations. In thermal power station, the thermal energy generated by burning coal, diesel or gas is used to produce steam. The steam thus produced is used to rotate the turbine. While the turbine rotates, the coil of wire kept between the electromagnet rotates. Due to electromagnetic induction, electricity is produced. Here, heat energy is converted into electrical energy. In thermal power station, heat energy is converted into electrical energy, and the thermal energy generated by burning coal, diesel or gas. Next, advantages and disadvantages of thermal power station. The fuel used is quite cheap and less initial cost as compared to other generating stations, and it can be installed at any place irrespective of the extensions of coal. The coal can be transported to the site of plant by rail or roads. And disadvantages are it pollutes the atmosphere due to producing large amount of smoke and fume, and higher maintenance cost and operational cost, huge requirement of water. These are the advantages and disadvantages of thermal power stations. Hydel power stations. In hydel power stations, the turbine is made to rotate by the flow of water from dams to produce electricity. Here, kinetic energy is converted into electrical energy. In hydel power station, kinetic energy is converted into electrical energy. So, hydel stations have long economic lives and low operating cost. And advantages and disadvantages of hydel power stations. Advantages: once a dam is constructed, electricity can be produced at a constant rate, and hydropower is a fluid by water, so it's a clean fuel source. Hydroelectric power is not that expensive. These are the advantages. And disadvantages are dams are extremely expensive to build and must be built to a very high standard. People living in village and towns that are in the valley to be flooded must move out, and fish populations can be impacted if fish live in the dam. So these are the disadvantages of hydel power stations. Next, atomic power stations. In atomic power stations, nuclear energy is used to boil water. The steam thus produced is used to rotate the turbine. As a result, electricity is produced. Atomic power stations are also called as nuclear power stations. Atomic power stations are also called as nuclear power stations. Here, nuclear energy is converted into mechanical energy and then electrical energy. In atomic power station, that is or nuclear power station, nuclear energy is converted into mechanical energy and then electrical energy. So advantages and disadvantages of atomic power stations are: no air pollution is produced, no greenhouse gases like carbon dioxide, and countries can limit their need for imported oil. Immense amount of energy produced, and only minute amounts are needed for lots of energy, and small amount of waste produced compared to energy that it creates. And disadvantages are possibility of accidents, disposal of the radioactive waste, and accidents can cause damage for thousands of years if not millions of years. So these are the advantages and disadvantages of atomic power station. Atomic power station also called nuclear power station. And last one, windmills. These are the another source of electricity. In windmills, wind energy is used to rotate the turbine to produce electricity. Here, kinetic energy is converted into electrical energy. And already we know that in hydel power station, kinetic energy is converted to electrical energy like windmills. And advantages and disadvantages of windmills are renewable energy. This is the importance. Renewable energy and pollution free. Windmills are renewable energy and pollution free, cost effective. And disadvantages are unreasonable wind strength and threat to wildlife and noise disturbance. These are the advantages and disadvantages of windmills. Next we will go to see cell. Cell, a device that converts chemical energy into electrical energy, is called a cell. Electrical cell, all types of electrical cells have two terminals, a positive terminal and a negative terminal. In a dry cell used in your homes, the central carbon rod is the positive terminal and the zinc contained is the negative terminal. Positive terminal denoted plus symbol and negative terminal denoted as minus symbol. Next, the cell electric current cells are classified into two types. They are primary cells and secondary cells. So cells have two terminals, positive terminal and negative terminal. Positive terminal is carbon rod and negative terminal is zinc. So cells are classified into two types, primary cell and secondary cell. Primary cell, they cannot be recharged, so they can be used only once. Hence the primary cells are usually produced in small sizes. A primary cell is a battery that is designed to be used once and discarded, and not recharged with electricity and reuse like a secondary cell in general. The electrochemical reaction occurring in the cell is not reversible and rendering the cell unrechargeable. So examples, the primary cell examples are cell used in clocks, watches and toys etc. are primary cells. See next, secondary cells. A cell that can be recharged many times is called secondary cell. But primary cell we can not be recharged. So the primary cell can use only one time. But secondary cell we can be recharged and use many times. A secondary cell is a type of electrical battery which can be charged, discarded into a load and recharged many times, as opposite to a disposable or primary battery which is supplied fully charged and discarded after use. The below pictures are examples of secondary cells. Secondary cells are used in mobile phones, laptops, emergency lamps and vehicles batteries. These are the examples of secondary cells. Battery. What is battery? A container consisting of one or more cells in which chemical energy is converted into electricity and used as a source of power. We call cells as batteries. Only when two or more cells are combined together, they make a battery. A cell is a single unit that converts chemical energy into electrical energy, and a battery is a collection of cells. So two or more cells are combined together, they make a battery. Electric circuits. Electric circuits are made up of electrical components. The electrical components are connecting wires, electric cell, light bulb, circuit board. These are the electrical components. So electric circuits are made up of electrical components. These components must be joined together without any gap in between to form a closed circuit, and components refer to the light lamp, wires, battery. So these are the electrical components. Inside view of torchlight. Circuit breaks, sliding switch and bulb turned off. An electric circuit is the continuous or unbroken closed path along with electric current flows from the positive terminal to the negative terminal of the battery. A circuit generally has a cell or battery, a source of electric current, and connecting wires for carrying current, and bulb, a device that consumes the electricity, and a key or a switch. This may be connected anywhere along the circuit to stop or allow the flow of current. So circuit breaks, gap. If sliding switch off. If circuit closed, no gap here. Next, open circuit and closed circuit. Open circuit. In a circuit, if the key is in open, that means off conditions, then electricity will not flow and the circuit is called an open circuit. The bulb will not glow in the in the circuit. That means in open circuit the bulb will not glow, and in a circuit the key is in open. That means the switch in off condition. The first picture denoted as open circuit. Here battery, the cell symbol and battery symbol and key here in open circuit, the key in open, that means off, and electric bulb not glow. Next, closed circuit. In a circuit, if the key is in closed, that means on condition, then electricity will flow and the circuit is called as closed circuit. The closed circuit, the bulb will glow in this circuit. See this second picture, closed circuit, the cell, battery and key. Key is the symbol, closed key symbol, and bulb will glow in closed circuit. Next, types of circuits. There are three types of circuits. First one, simple circuit. Second one, series circuit. And the third one, parallel circuits. Let's see one by one. First, we'll see simple circuit. A circuit consisting of a cell, key, bulb and connecting wires is called a simple circuit. First, a key, lamp light and battery. Here in simple circuit, K1 means key. Second one, K1 means key and or switch. Second, L1 means bulb and C1 means battery. This connecting wire is called a simple circuit. Second, series circuit. If two or more bulbs are connected in series in a circuit, then the type of circuit is called series circuit. If any one of the bulbs damaged or disconnected, the entire circuit will not work. Here, key, K means key or switch. The bulb will connect in series sequence. L1, light 1, that means bulb 1, bulb 2 and bulb 3. 3 bulbs are connected in series circuit, and C1 means battery. If any one bulb or connection damaged, the entire circuit will not work. And third, parallel circuit. If two or more bulbs are connected in parallel in a circuit like this, then the type of circuit is called parallel circuit. If any one of the bulb is damaged or disconnected, the other part of the circuit will work. So parallel circuits are used in homes. Symbols of electric components. In the circuits discussed above, we used in the figure of electric components. Use electric components in completer circuit is difficult. So symbols of the components and used instead of figures. These symbols used in electric circuits, even complicated circuit, can be easily understood. The electric components are electric cell, battery, switch open, switch closed, electric bulb and connecting wires. And figures, symbols and remarks are here. Electric cell means longer terminal refers positive and shorter terminal refers negative. Battery means two or more cells connected in series. And switch open, switch is in off position. Switch closed means switch is in on position. And electric bulb, the bulb does not glow. And in electric bulb, the first symbol, the bulb does not glow, and second symbol is the bulb will glow. And connecting wires, used in connect devices. Next, conductors and insulators. Conductors, the rate of flow of electric charges in a circuit is called electric current. The materials which allow electric charges to pass through them are called conductors. For examples, copper, iron, aluminium, impure water, earth, and all metals are conductors. And insulators means non-conductors. The materials which do not allow electric charges to pass through them are called insulators or non-conductors. For example, plastic, glass, wood, rubber, china clay, ebonite, etc. These are the examples of insulators or non-conductors. Last one, safety measures to safeguard a person from electric shock. Switch off the power supply. Second, remove the connection from the switch. Third one, push him away using non-conducting materials and give him first aid and take him to the nearest health center. Thank you, children. We have completed Unit 2 Electricity. Let's see the next session.